Which of the following atoms can have more than an octet of valence electrons when it shares electrons with other atoms? A. Sulfur, B. Nitrogen, C. Carbon, or D. Hydrogen? The size of an atom's valence shell determines the maximum number of valence electrons that can surround the atom when it shares electrons with other atoms. The outermost or valence of atoms belonging to the nth period is the nth shell, and the maximum number of electrons that can be assigned to this outermost shell is 2n squared. For the first row elements, n equals 1, and 2n squared is 2 times 1 squared, or 2. Therefore, hydrogen cannot have more than 2 electrons surrounding it when it shares electrons. Choice D is incorrect. Hydrogen cannot have more than an octet. It can even have more than a duet. For the second row elements, n equals 2, and 2n squared is equal to 8. Of these 8, we can imagine 2 electrons being assigned to the 2s subshell and 6 to the 2p subshell. Therefore, second row elements like carbon and nitrogen cannot have more than an octet. Choices B and C are incorrect. For atoms belonging to the third row, in addition to the 3s and 3p subshell, there is also a 3d subshell, so the valence shell can accommodate up to 18 electrons. Therefore, sulfur, which belongs to the third row, can have more than 8 valence electrons surrounding it when it shares electrons with other atoms. The correct answer is choice A, sulfur. Sulfate is an example of a structure where sulfur has more than 8 valence electrons surrounding it. In the structure shown here, there are 12 valence electrons around the sulfur atom. This is one of several resonance structures for sulfate. This particular resonance structure is believed to be more significant than this one, where all the bonds are single bonds and the sulfur atom has an octet around it. The reason is that the sulfur atom on the left has a formal charge of 0, whereas the sulfur atom on the right has a formal charge of +2.